Okay, welcome to this presentation where we want to look at the system of equations. In this regard, we want to look at linear and quadratic equations. By that, we mean how we can solve these equations simultaneously. Now, before I go any further, I must mention that my name is this is my name. Kamban Phiri. All right. That is my name. You can reach me on 0978 56 58 76. You can WhatsApp me on that one. Then my colleague is Bondo Chaomba. You can reach him on 0978 56 58. Sorry, I'm repeating my number. 0979 67 3809. So in case you want to contact any of us, please, those are our contactee lines. All right. So let's get back to business. Like I said earlier on, you are welcome to this presentation and welcome to our channel. I would encourage you to subscribe and turn on the notification button so that each time we upload a new video, you should be able to see it and possibly watch. Please, you can share the link with your friends, with your colleagues, with your relatives. All right, so back to business. In case you have been struggling to solve simultaneous equations involving linear and quadratic equations, here is a solution for you. I'm here to provide that solution. But before we look at a specific example, maybe we need to remind ourselves what a linear equation is. So we are saying a linear equation is an equation of this form. That is our linear equation, where A and B here are constants. By constants, we mean they are numbers. But A must not be equal to 0, because the moment A is equal to 0, then it will cease to be a linear equation. All right? Examples of linear equations are, these are some of the examples. X plus 4y is equal to 10, it is a linear equation. Y is equal to 4 plus 5x. X plus 10 is equal to 20. All these are linear equations. Now, if you look at the first two cases, they are linear equations in two variables. That is, we have got x and the y. That is the x and the y. So those are our linear equations. All right. Then, how about a quadratic equation? We are saying a quadratic equation is an equation of this form: ax squared plus bx plus c, where a, b, and c are constants, but a must not be equal to 0. Take note, it must not be equal to 0. Otherwise, it will change from quadratic to a linear function or to a linear equation. All right, so these are the examples of a quadratic equation. Examples of a quadratic equation. All right. Now, again, by quadratic, you are able to identify that it is quadratic by looking at the highest power, which is a 2. So if the highest degree is a 2, it means that kind of an equation is quadratic. And the degree, to some extent, we indicate the number of possible solutions if at all you were to solve that equation. So because the degree is a 2, it means that we have got a likelihood of getting 2 possible solutions upon solving such kind of an equation, if at all it were possible to be solved. All right. So in this case, we look at the example. Sorry for that. We look at examples. So let's look at an example. We say solve the following simultaneous equations. So depending on the examining body, the marks differs. At times you can be given 5 marks for such kind of an for such kind of equation. So what are the equations? 2x plus y. The answer is 7. And the xy minus x squared. The answer is 4. Okay, so how do we solve? All right, so let's take our time to work out this one. So if you want to solve, you realize that we have got 2 equations here, equation 1 and equation 2. So you get the linear equation and substitute it into the quadratic equation. It is easier that way. But now, before you do that, you must make one of the variables in equation 1 as your subject. What do I mean? We have got 2x plus y. This is equal to 7. So you might decide to make y your subject because it is easier. So you say y is equal to 7 minus 2x. Okay, so this is your newly created equation, which should be substituted in equation 2, but only where there is x. All right, so what are we saying? We are saying this would, we imply that we'll have only where there is y, take note, we'll say x, open the bracket. Where there is y here, we are going to put 7 minus 2x. We close, minus x squared is equal to 4. I hope that is okay. Okay, so allow me to erase this. All right, so this is equal to, we distribute the x inside the bracket. So we have got 7x minus 2x squared. Okay, I hope you're getting me clearly. All right, so then there's minus x squared. We can take the 4 to the left-hand side and it becomes minus, then we remain with a 0. What does it mean? So when you work out this part, you have got negative 3x squared plus, when you deal with this, it will be plus 7x minus 4 is equal to 0. Now, at this stage, you can use any method of solving quadratic equations, all right? Okay, so if at all you're able to factorize, you can factorize. So I'll try to use, I'll say by factorization here. All right. So now, by factorization, in this case, we mean we need to get the product. Our product is the first -3 by -4. That's our product. All right. We say A by C. So this will produce a 12. Then our sum is B, which is this one. So our sum is this. So our sum is 7. So we need to get the factors of 12, whose sum is 7. These factors are 3 and 4. All right. So we can proceed. We'll say this is equal to -3x squared minus plus 3x plus 4x. I'm getting this. All right, and just add the x. Minus 4, this will produce a 0. So when you look at this stage, and that, when you look at these two terms, you realize that there is a common factor. So we apply common factor now. And our common factor here, in this case, is a -3x. So negative will produce a positive here. 3x into 3x squared is x, minus both negative into positive is negative. All right, that is a negative number into a positive number. You get a negative number. 3x into 3x is a 1. Again here now, here what is common is a +4. We'll say open bracket x minus 1. You close, this is equal to 0. All right, we proceed. Okay, so we proceed. We proceed. Okay, so allow me to erase this. So at this stage, we get what is common, which is this. So say x minus 1, just one of that. Then you get what is in here outside the bracket, and this you put them in brackets. So you have -3x plus 4 is equal to 0. So using the zero product rule, we are able to find the values of x. We are able to find the values of x. So how do we do it? We'll say x minus 1 is equal to 0, or it is -3x plus 4, which is equal to 0, or it could be both. So this implies that x is equal to 0 plus 1. This will further imply that x is 1, or we'll say -3x is equal to 0 minus 4, or -3x is equal to -4. Dividing both sides of the equation by -3 will produce x to be equal to 4/3. So these are the two possible values of x. So after getting those two possible values of x, we must get the corresponding values of y. All right? We must get the corresponding values of y. I hope it is okay. Please, let's enjoy these things. So how do we get the corresponding values of y? It's very simple. We just do the substitution. All right, so we can pick the original equations. Take note, this is the continuation. So, or we can pick this equation, which is like our third equation. So say y is equal to 7 minus 2x. Now, when x is equal to 1, what is y? I think that's what we want to find. So this will imply that y will be equal to 7 minus, while there's x here, we put a 1. So it will be 2 by 1. What do we get? So it will be 7 minus 2, and the answer is 5. That is our answer. Then we say when x is equal to 4 over 3, what is our y? Right, so in the same vein, we say this will imply that my y is equal to 7 minus 2. X is 4 over 3. Okay, so this will imply that y is equal to 7 minus, so when you multiply 4 by 2, you get 8 over 3. Here you can say, you can introduce a dummy 1. Then you cross multiply. Here, you can cross multiply. 7 by 3 is 21. Minus 1 by 8 is 8. Divided by 1 by 3, which is the 3. All right, so we'll say y is equal to, what is 21 minus 8? You get 13 over 3. Or you can divide this since it is an improper fraction. You say 3 into 13 is 4. 1, remainder 3. Those are our answers. So we can conclude and say, therefore, x is equal to 4 over 3 when y is equal to 4 and a third. 2, x is equal to 1 when y is equal to 5. Those are our answers. Alternatively, another way of writing this is you can say or 1, 5 and 4 over 3, 4 and a third. Those are the possible solutions that will satisfy those two equations. So that is how you solve simultaneous equations involving linear and quadratic equations. I hope it is clear. Please subscribe to our channel for more videos and the lessons. Subscribe, and share with your friends. In case you want to contact us, use the numbers that I gave you earlier on. Thank you so much. Please subscribe, and subscribe.